Alright, so we're looking at the PhET gas properties simulation, and we're going to be starting off with 5 light particles just to answer the first question. Notice the temperature, the pressure gauge. We can control the heat down here. We can change the volume over here. Just watch the particles and how they're moving and observe. Notice when they bounce against the container walls, when they collide with each other, and record your observations. Okay, if at any time you need to go back and re-see something, then pause, rewind, whatever you got to do, and move on to adding 50 light particles and see what happens. Make your observations and do your write-up regarding what you observe. Okay, so now we're going to go into the energy histogram. And there that is over here. We'll move this over a little bit. So notice what that shows us. And now we're going to add the 50 heavy species, just so we have a mixture of particles. And we'll click the more details so we can see what everybody's up to. Alright, so we are, again, comparing the graphs for the heavy and the light particles. So we're looking at the shape. So notice this and a distribution. And now we're going to heat and cool just to see what happens. So kind of keep your eyes on these graphs right here. Let's heat and see what happens to their shape. Kind of let the particles adjust a little bit before we really compare. So these graphs any different over here than they were before. All right, we'll cool it back down just so you can take a look at that again. There we go. And next we will pop up this species information. There it is. This gives us average speeds in addition to what we see on the graphs. Alright, okay, so now we're going to move on to looking at the individual gas laws. And we're going to reset everything. And I'm going to put 50 particles in. And we're going to hold temperature constant. And we'll see what happens. So we're going to squish in the volume, shrink the volume, compress, if you will. Notice what happens to the pressure. Again, let the temperature, let's get back to around 300. And then take a look at this pressure. Now we'll squish some more. Again, watch what the particles are doing. So again, as the temperature gets back to what it was before, now we can take a look at what the pressure looks like. And we'll see what happens. Well, let's see if we can go all the way here. How far can we go? That's as far as it'll let us compress. And let's expand it back out just so we can see that difference. Again, as the temperature gets back to 300 now, take a look at the pressure. Alright, record your observations and answer the questions. And next we'll move on to Gay-Lussac's law. And okay, so we're going to reset. And we're going to add 50 particles. And we will keep volume constant. Okay. So now we're going to add some heat. See what happens to the pressure. Add some more heat. See what happens. Cool it back down. It's below where we started in the first place. Check that out. Cool it a little more. Alright, and then lastly we'll do Charles' law. So I'm going to hit reset and we'll keep volume constant temporarily until we get the particles in. And now we'll keep the pressure constant. Oops, hold on. Oh, let's reset that. We'll let equalize first. I'm going to keep our container this big to begin with, and then we'll make it constant pressure. So let's let it get up to get those particles moving, get a pressure reading. Now we'll click constant pressure. Okay, so now we can start looking at Charles' law, so our observation. So we are going to heat it up. Notice what happens to the volume. There's, of course, limits to how far this little guy's allowed to walk, so that's kind of, that didn't help at all. Alright, and cool it down. So notice there's a little bit of lag time when we make an adjustment. The particles have to kind of get the message of what's happening. Oh, I'm going back. There we go. That's where they should have been in the first place. Right. And now we'll move on to Dalton's law of partial pressures. So let's reset this. Okay, so we're going to do volume as a constant parameter. And we're going to see what happens when we look at different numbers of particles and different types of particles. See what that does. So this is our 50 heavy particles. Again, just let the pressure equalize. I know it jumps around a lot. So let's say that's 0.28. Let's do 0.28, call it a day. Okay, so then we've got 50 light particles. We're going to get rid of the heavy and put in 50 light. See what happens. So again, we want to let it equalize. Notice we're 300 Kelvin for all of these, so we want to make sure we're comparing the same temperature. And we're getting pretty much the same reading, so 0.28. Again, I know it's shifting around. It went down. It'll go back up again. There. All right, and we'll look at what if we had 25 of each for a total of 50. Let's see what that does. Oops, 25. See what that does for us. So 25 of each particle. And this temperature is supposed to be at 300. I'm just going to adjust it back down to that. Oh. Okay, there's a 300 Kelvin. 50 particles. Notice we're at that 0.28 again. All right, so let's go to 100 heavy particles. Let's just see what happens if we double. So we were at 50 in each of the other previous scenarios, and now we'll do 100 total for the heavy. Just give it a minute to settle in. Oh, let's get this temperature back to 300 also. You're supposed to be adding my molecules at the right temperature, and why it's So we're getting like 0.5, say 0.52. All right, and then let's try 100 light particles. 0, and switch it to 100. And let's let the pressure just kind of equalize, double check, make sure our temperature is at 300 still, like it's supposed to be. And our pressure is back up to, well, around where it was before. So 0.4, let's say the 0.52, because again, it's jumping up and down. Okay, so take a look at the questions, make sure you fill everything in. If you need to rewind and review something, do that, and then complete the rest of the sheet, and we will talk about this in class.